Hello and welcome everybody. So, if you recall last time we talked about this idea of reflections here, where we were flipping objects over lines, points, things like that here. So, another one of the basic transformations that I'm sure many of you are familiar with is this concept of rotations, where instead of flipping, we're going to be spinning here. We're going to be turning an object around some things here. So, note that in this situation, if we want to think about a rotation, we want to describe this idea of rotation, we're going to need several things here. Well, intuitively, one thing what we're going to need is basically we're going to need a center. We're going to need some sort of center here, central point, that we're going to be rotating around. You're going to need a center here. So let's put a center down. I'm going to call this point here O, right? So that is going to be our fixed point here. This is going to be where we're sort of going to stick our virtual pin in the paper here, and then we're going to use this and rotate the entire object around here. Now, of course, in addition to the center here, we're also going to need some sort of angle here. We're going to need know how far we're going. So for instance, something like this here, let's say we have our angle something like this. Let's say our angle here happens to be something like that. We can have an X degree angle like this here, right? So for instance, in this situation, let's say we want to take a look at point A. Now, our intuition tells us that basically we can just kind of rotate this here and rotate it so it looks something like that, right? So we'll kind of do this sort of thing going on here. So in this case, we can kind of set it up like this. We're going to need an angle like this. So note that one important thing about this here is that when we're rotating, we want to make sure that these distances remain the same here. So we can talk about here, we can say that this is A prime here, but we want to make sure that these distances are matching here. So for instance, OA and OA prime should be the same distance here. Similarly, if we did OB, right? So here's OB here, and then we want to do the same sort of thing where we just copy this angle here. And again, note that this is an approximate sketch here. These are just sketches. This isn't actually the entire thing. We want, again, this angle here to match the same thing. Here's X as well, and here's going to be B prime up there. And we can see that this is our setup. So this line segment moves from here to here. So we seem to have this sort of thing here. And we can notice that we have two triangles like this. We have ABO and A prime B prime O. We can see that essentially what's going on is this triangle has been rotated into a new position here. So that actually gives us this idea of a definition here. So we can mention this definition of a rotation in the plane. So a rotation in the plane looks something like this here. So we can see that it is a rotation in the plane of a point P around a fixed point O of a given angle X is defined so that the image is a point, the image P prime is a point, such that first off we want to make sure that this angle is preserved. So this represents our angle here. And then the OP equals OP prime means that we know that the distance is not going to change here. When we're going to be doing our rotation, we want to make sure that in this case here, so for instance, so going back to our picture, OA and OA prime are the same. We know that A is not going to sort of like fly off in this direction here or shrink down. We want to ensure that it's the same thing here. So we kind of keep this idea of a rotation in mind like this, okay? So the notation for rotations is very similar to the notation for reflections here. So you can see that our notation looks something like this here. We can see that we have something like this, and I'll just run through this here. Again, we note we have our pre-image and our image here. Right? Just like with reflections here. Here, this capital R represents the rotation as opposed to lowercase r for reflection. I know the textbook kind of does this backwards, but let's use this notation here. The capital R represents rotation. Note that this point here, O, represents the center of rotation. Now, in general, when we write things, if there is no center of rotation, you may assume it's the origin. But for most cases, we want to be sure we want this to be here. And then we have our 90 degrees. This represents our angle of rotation. Now, some of you may know, wait a minute, something seems to be a little off here. Because if we have a 90-degree angle of rotation, so for instance, if we go back to our picture here, and X happened to be 90 degrees, what prevents me from just, we did this, we just went clockwise like that. What prevents me from doing this and going the other direction? Right? Because 90 degrees doesn't tell you which direction to go, whether it's clockwise or counterclockwise. Luckily, that's sort of baked into what's going on here. When we deal with this sort of thing, when you have a 90-degree angle here, the idea behind this is that, in general here, I'm just going to go ahead and mention this on the side. When you have a positive angle, that's counterclockwise. Now, it seems kind of counterintuitive that a positive angle means counterclockwise, but my guess is that somebody just decided, you know what, we're going to use positive angles as counterclockwise, and we're just going to leave it as such, and no one really questioned it here. And conversely, we know our negative angle, in this case, is going to be clockwise here. So in this situation here, we actually, by putting in the sign of the angle, the SIGN of the angle here, this actually bakes in the direction that we're going. So we can either go left, or so we can either go clockwise or counterclockwise based on the sign of that particular angle here. So in this case, this is a reflection around the origin, counterclockwise 90 degrees of point A will yield us point A prime. Okay, and then after this, now we're going to see how this works in the coordinate plane.